The last page of 4.3 introduces us to the idea of exponential equations. I would say 90% of exponential equations, or even 95%, don't fall into this category. But it's an easy way to solve, and it's the principle of exponential equality, which says that if a to the x equals a to the y, then x is going to be equal to y. So that means if the bases are the same, the exponents are equal. Bases are the same, the exponents are equal. So the goal is to make the exponents the same. So for example, with this being 2 to the 3x minus 5 equals 16, you could say, can 16 be written to a base of 2? The answer is yes. It's 2 to the 4th power. So that's where they get that 2 to the 3x minus 5 equals 2 to the 4th. So the bases are the same. So that means that the exponents have to be equal. So 3x minus 5 is equal to 4, 3x is equal to 9, x is equal to 3. Bases are the same, exponents must be equal. And then you can check your answer. It's not as important to check your answer on these guys as it is when we get into the logarithmic equations, if you remember. Do you want to start that? Thank you. So here's a problem that says if I had 1/4 to the x, well, the question is, can 64 be written to, or 1 over 64 be written to as 1/4 to some power? Well, the answer is yes. This would be 1/4 to the x, and this would be 1/4 to the 3, because 4 cubed is 64. So now the bases are the same, so the exponents must be equal, so x is 3. Now, this is one where you have to be very, very, very careful, because 2, well, I guess it could be written theoretically to a base of 4, if you knew what you were doing, but 4 can be written as a base of 2. So you could say, well, what am I going to do? Well, I'm going to take 4, and this is to the x squared, equals 2 to the x. I'm going to rewrite 4 to a base of 2, and 4 is the same as 2 to what power? 2 to the 2nd, 2 squared. Now the properties of exponents says that, remember, you're going to multiply. You have a to the m to the n power is going to be a to the m multiplied times n. You multiply the exponents. So 2 to the 2x squared equals 2 to the x. So now the bases are the same, which means the exponents must be equal, or that 2x squared equals x. And this is one of the largest problems that people have, is that you want to go ahead, just divide through by x. Can't do it. It's a quadratic. You want everything on the same side. Bring all your x's to one side. That leaves 0 on the other. So you're going to factor out a greatest common factor of x. This is 2x minus 1 equals 0. Or x is 0, x is 1/2. There are 2 answers. It's a quadratic, it's a maximum of 2 answers. Now this problem is getting us into the wonderful world of college algebra, because it's going to use 2 properties of exponents. It's going to use this property, and it's going to use this one. It says that a to the m times a to the n, if the bases are the same, you add the exponents. This is going to use the first one, which says e to the 4 to the x power is e to the 4x times e to the x squared equals e to the 12. Now, remember, if we're using the property that says if the bases are the same, then the exponents must be equal, that means what I'm going to be looking for in order to use that property is there's going to be a to the x has got to be equal to a to the y in order to say that x equals y. So that says I've got a single thing raised to a power equaling to that same thing raised to a power. And if you notice, how many things do I have here? I have 2, not 1. I've got 1 on this side and 2 on this. I need to bring it together, and that's where this property comes into play. So this then becomes, if the bases are the same, you add the exponents. And now the bases are the same, so the exponents must be equal. So that, write it in standard form, namely x squared minus 4x, or plus 4x, minus 12 equals 0. And hope it factors, and it does, thank goodness. This is x plus 6, x minus 2 equals 0, so that x is negative 6, x is positive 2. The domain on this guy is all real numbers. You're going to say, well, why? It's e to a power. You don't see any denominator or any radicals as part of the exponent. So as a result, it's all real numbers. My biggest fear was whether or not I was going to have to use a quadratic formula on that because I didn't have enough room. And that's what we've been working on in intermediate algebra. We've been working on a quadratic formula.